In this lesson, Cycle 1, Lesson 5, we're going to introduce another type of function, this time periodic functions. So, at its most basic, a periodic function is one whose graph repeats itself at regular intervals. So here is a picture of a graph that's repeating itself. We can add arrows onto the end to indicate that it's going to keep doing this. If this was on Desmos, I might be able to zoom out and just see that this up and down wave type shape, as I'm going to describe it, could go on indefinitely to the left and to the right. So periodic functions have to have something that's sort of like this, because, in other words, they have to have some sort of wave type look to them, otherwise they wouldn't be able to repeat. If they didn't have some sort of maximum, some sort of minimum, then then there wouldn't be any chance of repeating a certain section of it. So, more about that once we get into it, but here are some definitions we're going to need to know in order to talk about periodic functions. And the first thing I'm going to talk about is a cycle. I know the term period comes at the top, but I'm going to actually go to cycle first. A cycle is the shortest part, or let's call it the smallest section of the graph that repeats. So let's highlight this in green. Let's say I was to start here at the origin. The origin is right here, right, where I just put that green dot. If I was to start at the origin, this graph goes up, up, up until it gets to 1. I can read on the y-axis. Then it starts to fall again, gets back to the x-axis, drops below it, gets down to -1. Starts coming up again, gets back to the x-axis again, there. If I stop there and look back, I can imagine that I'm starting over again, right? So I started here at the origin, and I was moving in an upwards direction. So once I get back to the origin, moving in that upwards direction again, that's where I'm starting over. So the cycle, it doesn't start over here, does it? Because even though I'm back at the x-axis, I'm moving in a different direction. So in order to be starting over, I have to be back in the same vertical location, but I also have to be moving in the same direction, like this. So there's one cycle. Just trying to get rid of some of this extra stuff. All right, so smallest section of the graph that repeats. If I was able to, I could imagine reaching in and grabbing that green section of the graph and then just almost using it like a stamp over and over again to repeat the graph. So if that's the cycle, what's the period? The period is the length of one cycle. And we're going to measure that on the x-axis. Or the horizontal axis anyway. So if, say this had a scale of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, etc., the period for this one would be 8, because it would start at 0 and it would go up to 8. The horizontal length of that section of the graph is 8 units long. So that's what we mean by the period. So again, the length measured on the x-axis. Just want to get rid of all the extra clutter that I don't need, so I do want to keep that highlighted though. All right. Maximum, of course, would be the highest point on the graph. The highest point. And the maximum is going to repeat, right? For this one, for this graph, the maximum occurs at 1. But it happens over and over again. It's going to keep happening repeatedly because it's periodic. The minimum would be the lowest point in the graph. That would be down here at -1. But that's going to repeat over and over as well. The axis of the curve is sort of like a horizontal axis of symmetry. We know what an axis of symmetry is for a quadratic. It's that vertical line that cuts the quadratic in half. And then we could fold that quadratic, that parabola, on the axis of symmetry, and the two halves of the quadratic would match up. So this is sort of the same thing, but it's different as well. So the axis of symmetry is... iPad, why did you do this to me? Let me try again. Sometimes my iPad does funny things. This might be one of those days, but we'll see. Yes, it's going to do that to me. All right, so I'm going to have to just draw it freestyle. Here is my axis of symmetry for this one. In other words, if I were to take the highest point and the lowest point and take the midway between them, that would be my axis of symmetry. Sorry, axis of the curve. It's not actually an axis of symmetry, is it? Because if I was to fold this graph in half along the axis of the curve, the two halves still wouldn't match up. It's not symmetrical, but it's in the middle and it's horizontal. So the axis of the curve is always a horizontal line halfway between the max and the min. Max is short for maximum and min is short for minimum. If I want to know what the equation of this axis is, since it's halfway between the max and the min, I can just average those two values. So if the maximum is it's the y value of the highest point, and the minimum is the y value of the lowest point, then the equation of the axis is going to be a horizontal line, so it's going to be y equals something. It's going to be the max plus the min, so the y value of the maximum plus the y value of the minimum, divided by 2. The amplitude is the distance from the axis of the curve to the maximum or the minimum. So we use A to represent the amplitude. Maybe I'm just circling it, I'll highlight it. So we use A to represent that, and that is going to be this distance here. So from the axis to the maximum, again, we represent it with the letter A, or it could be the distance from the axis to the minimum. Those are going to be the same, aren't they? Since the axis is right in the middle, it doesn't matter whether I do the distance to the max or the distance to the min, they're going to be equal either way. And we can get an equation for that. So it's half the distance between the maximum and the minimum, right? If this is the minimum here and this is the maximum here, the amplitude would clearly be halfway in between, or half the distance from the max to the min. So this time, instead of averaging the max and the min, I could add the maximum and the minimum. Sorry, I could subtract the maximum from the minimum and then divide it by 2 to get half that distance. So in that case, A, because A is for amplitude, is equal to max minus the minimum divided by 2. So these are the formulas, a couple formulas that we can use to help us figure some things out. Pardon my cough today. And well, I guess it's easiest if we just jump into a couple of examples. I see 1, only two examples, not so bad. The graph to the right represents the motion of a piston. The horizontal axis represents time. The vertical axis represents the height of the top of the piston. And you can see on the scale that this piston, whatever we're measuring, it goes below, it goes down to -6, appears to be as low as it goes. And it goes up to +1. And this is periodic for sure. It's not that smooth wave like you can see in the first example, but it definitely repeats. If I were to start here at the y-axis and then just follow this along, once I get here, it starts over. If I were to take that green part, I could just repeat that green part over and over again to get my graph, right? So is the function periodic? As I just explained, yes, it is. The graph repeats. That's what makes it periodic. Determine the following values: maximum, minimum. Okay, well, maximum is 1, right? Let's use some highlighting. There's the maximum up there at 1. The minimum, that's down wherever, -6. The equation of the axis, so that's going to be that halfway in between. So it's going to be somewhere in here. I'm going to erase that and do it more properly, more accurately in a second. But remember, we have an equation. We can do max plus min divided by 2. And it's going to be horizontal, a horizontal line, so it'll be in the form y equals. So the maximum plus the minimum divided by 2. It's not a lot of space here, so we'll go horizontally. 1 plus -6 is -5. Divided by 2 gives -2.5. So -2.5 would be about here on the axis, on the y-axis. So let's see if we can draw a horizontal line for that. It might act funny for me again. If it does, I'll give it up. No, let me do it that time. So there's the axis of the curve. That cuts the graph in half vertically. So there's the same distance above the axis of the curve to the maximum as there is below the axis of the curve to the minimum. The amplitude is going to be the distance from the axis to the max or to the min. And so I can just look at it. I could count the units, 1, 2, 3.5 units. Or, if I wanted to, I could use the formula. Amplitude equals the max minus the min, so 1 minus -6 over 2. Simplify that. That becomes 1 plus 6 over 2, which equals 7 over 2, which equals 3.5, which is what I just got by counting, but, it's another way of getting it. Now, period, I sort of used up my space for the period here. Maybe I'll just move that over a bit and do period over on the right. So the period is the length of one cycle. It's easiest to you can find the period anywhere, but it's easiest if you just start at the y-axis like I did here and just go until it repeats, because then wherever it stops, you'll know that's the length of the cycle. So in this case, the green highlighting stops at 6 on the x-axis, so it starts at 0, goes to 6. That means the length of the period is 6 units. Or I guess 6, seconds? It doesn't say what the units are in. Oh, yes it does. It says the units, the time is given in seconds. So the period is 6 seconds. And I guess I could give units for the other things. Like the equation of the axis is at -2.5 centimeters, and the amplitude is 3.5 centimeters. That means the total distance that the piston moves up and down is 7 centimeters. Half of that is the amplitude of 3.5. And the middle, the axis of the curve, is at -2.5. get units on for all that. So those are the basic parts of a periodic function. There's other things we can do, such as creating our own following particular information that we're given, such as sketch the graph that satisfies the given properties. And so we're given things like the period, the amplitude, the axis of the curve, and a number of cycles. Okay, so here's the order. If you're asked to sketch something, here's the order I would start with. First, I would do the axis of the curve. Because the axis of the curve is an easy thing. It's just this horizontal line. And remember, the axis of the curve is at always y equals whatever the number is. So what this is telling me is that the middle of this graph is at y equals 1. So I'm going to just sketch that on there at y equals negative 1. At y equals negative 1, I'm just going to put a horizontal line here. There's my axis of the curve. The next thing I would look at would be the amplitude. And the reason for that is because that tells me how far to go up and down from the axis of the curve. So since the amplitude equals 3, if I start at the axis of the curve, start here and count up 1, 2, 3, my maximum value is going to be 3 units above the axis of the curve. And the minimum is going to be 3 units below it, right? 1, 2, 3, there's my minimum, because again, the amplitude is the distance from the axis of the curve up and down. So now I've got this idea that, okay, my graph, I'm just going to put a dotted line here, but my graph can't go above positive 2, and it can't go below negative 4. So now I'm getting some better ideas of what's happening.
Here are some results.
Sorry, Google just thought I was talking to her, but I wasn't. The period is 2 units. Okay, that would probably be the next thing I'd look at. So if the period's 2 units, then that means that I have to get 1 full cycle within 2 units. So I've highlighted, actually I'm not going to highlight the x-axis, I'm going to highlight the axis because I want to focus more on the axis of the curve. So within that green highlighted area, I could highlight this whole thing, maybe that's better. Within this green highlighted area, I've got to get a full cycle. So I've got to start and finish, be back where I started within 1 cycle, within those 2 units. So it doesn't tell me exactly where to start. Since it doesn't tell me where to start, I'm going to choose to start on the axis of the curve. I'm going to use purple. So I'm going to start on the axis of the curve, which means that when I'm done, when I get to 2 units, I have to finish on the axis of the curve. Within that space, I've got to get up to the maximum at some point, and I've got to get back down to the minimum, and then get back up to the axis of the curve again. So let's say, since I have to go to the maximum and the minimum, let's just make it easier on ourselves and say that we're going to cross back over the axis of the curve halfway. Maybe I'll hit the maximum halfway between those 2 points, hit the minimum halfway between those 2 points, connect my dots, and there's 1 cycle. So now I've got 1 cycle of a curve, of a graph that has a period of 2 units, has the axis of the curve at negative 1, it's got an amplitude of 3, all that stuff's been checked off. The last thing I would need to then consider is making sure I get the correct number of cycles. So I'm supposed to do 4 cycles. I need to repeat this exactly 4 times. So there's my first cycle. I could even call this cycle 1. My second cycle is going to be identical. So I'm going to hit the max, going to hit the axis of the curve. Notice how it's very tempting to put points here on the x-axis because it's nice and bold and it draws our eye. Avoid that temptation unless the x-axis happens to be your axis of the curve. My axis of the curve is negative 1, so I am putting my point on negative 1. minimum, back to the axis. Maximum, axis of the curve, minimum, axis. Maximum, axis, minimum, axis. So repeating the exact same curve over and over 4 times. There's cycle 1 I already highlighted. Here's cycle 2. Let's do a little highlighting so they can pop out a little bit better. Let's do cycle 3 in blue. And let's do cycle 4 in orange. So there's my 4 cycles. And I've checked off all the boxes. And that's the order that I would definitely tackle a question like this from. Always starting with the axis of the curve. And that's it for this lesson. Good luck with the practice questions.